Around 4.6 billion years ago, our solar system was a chaotic cloud of dust and gas. This solar nebula eventually coalesced under gravity, forming the Sun and the planets, including Earth. The young Earth, about 4.5 billion years ago, was a molten mass, gradually differentiating into layers as heavy elements sank to form the core and lighter materials rose to form the crust. During its early years, Earth experienced a monumental collision with a Mars-sized body named Theia, leading to the formation of the Moon. This period, known as the Hadean Eon, saw the planet bombarded by comets and asteroids, delivering water and organic compounds necessary for life. The early Earth was a volatile environment with extreme volcanic activity and a thin, nascent atmosphere composed mainly of volcanic gases. As the planet cooled, water vapor condensed to form oceans. Earth's position in the Goldilocks zone, not too close to the Sun to boil water away and not too far to freeze it, was crucial for maintaining liquid water, a vital ingredient for life. The emergence of life is believed to have occurred around 3.8 billion years ago during the Archean Eon. The exact mechanisms remain a mystery, but it is widely hypothesized that life began in hydrothermal vents in the ocean. These vents provided the necessary conditions for simple organic molecules to form and eventually give rise to the first single-celled organisms. For billions of years, life on Earth was microbial. Around 3.5 billion years ago, Cyanobacteria, a type of photosynthetic microbe, evolved. These organisms could harness sunlight to produce energy, releasing oxygen as a byproduct. This process, known as photosynthesis, was a game-changer for Earth's atmosphere and life. The oxygen produced by cyanobacteria initially reacted with dissolved iron in the oceans, forming iron oxide deposits on the seafloor. However, around 2.4 billion years ago, oxygen began accumulating in the atmosphere, leading to the Great Oxidation event. This rise in oxygen levels was catastrophic for many anaerobic organisms, causing the first mass extinction in Earth's history. Following the Great Oxidation event, Earth experienced significant climatic changes, including periods of extensive glaciation known as Snowball Earth events. These glaciations, occurring around 2.3 billion and again around 700 million years ago, covered the planet in ice, drastically affecting life and its evolution. Despite these harsh conditions, life persisted and diversified. The first eukaryotic cells, which are more complex than prokaryotic cells, emerged around 2 billion years ago. These cells had a nucleus and organelles, setting the stage for the evolution of multicellular life. The Neoproterozoic Era, beginning around 1 billion years ago, witnessed the rise of multicellular organisms. Simple algae and fungi appeared, followed by the first animals. The fossil record from this time includes enigmatic, soft-bodied organisms known as the Ediacaran biota, which thrived in the oceans. The Cambrian explosion, around 541 million years ago, marked a dramatic increase in the diversity and complexity of life. Almost all major animal phyla appeared within a relatively short geological period. This era gave rise to many familiar forms of life, including the first vertebrates, arthropods, and mollusks. The Paleozoic Era, spanning from 541 to 252 million years ago, was a time of significant evolutionary milestones. During the Ordovician period, marine life flourished, and the first plants began colonizing land. These early plants, such as mosses and liverworts, were small and required moist environments to thrive. The Silurian period saw the rise of the first vascular plants which could transport water and nutrients, allowing them to grow larger and occupy drier habitats. The Carboniferous period followed, characterized by extensive swampy forests that would later form the world's coal deposits. The increase in oxygen levels due to the proliferation of plants allowed for the evolution of large insects and amphibians. The first reptiles also appeared, capable of laying amniotic eggs that could survive on land, marking a significant evolutionary advancement. The Permian period, from 299 to 252 million years ago, saw the emergence of large herbivores and carnivores. Pangaea, the supercontinent, formed during this time, creating vast interior deserts and influencing global climate patterns. Reptiles diversified into various forms, some resembling modern mammals. However, the Permian period ended with the most severe mass extinction event in Earth's history, known as the Great Dying. Around 96% of marine species and 70% of terrestrial vertebrates went extinct. The causes are still debated but likely include massive volcanic eruptions, asteroid impacts, and climate change. The Mesozoic Era, from 252 to 66 million years ago, is best known as the Age of Dinosaurs. It began with the Triassic period, where life slowly recovered from the Permian extinction. The first dinosaurs and mammals appeared, and Pangaea began to break apart. The Jurassic period saw dinosaurs dominate the land. Giant sauropods roamed the earth, while theropods like Allosaurus were the top predators. The first birds evolved from small theropods, and marine reptiles such as ichthyosaurs and plesiosaurs thrived in the oceans. The Cretaceous period continued the dominance of dinosaurs, with iconic species like Tyrannosaurus rex and Triceratops. Flowering plants appeared and diversified, changing ecosystems and food chains. However, the era ended with another mass extinction event, likely caused by a massive asteroid impact near the Yucatan Peninsula. This event wiped out around 75% of all species, including all non-avian dinosaurs. The Cenozoic Era, beginning 66 million years ago, marks the age of mammals. With the dinosaurs gone, mammals rapidly diversified to fill various ecological niches. The Paleogene period saw the rise of many modern mammal families and the evolution of primates. The Neogene period followed, with significant changes in climate and the formation of grasslands. Early hominids appeared in Africa, leading to the eventual rise of humans. The Pleistocene saw the last ice age and the evolution of Homo sapiens, while the Holocene marks the rise of human civilizations and the current epoch. Humans have significantly impacted Earth's ecosystems and climate in a relatively short period. The Industrial Revolution, starting in the 18th century, led to unprecedented technological advancements, but also increased greenhouse gas emissions and environmental degradation. Human activity has caused the extinction of many species and altered natural habitats. Understanding Earth's history helps us appreciate the delicate balance of life and the importance of preserving our planet's biodiversity. As we face challenges such as climate change and habitat destruction, it is crucial to learn from the past and strive for a sustainable future. Would you like to see how mammals rose to dominance after the age of dinosaurs and the incredible journey of human evolution? If so, let us know in the comments and make sure to subscribe and stay tuned here. We thank you for watching.